Yo, what's up, guys? I'm just gonna show you how I derive the angle of twist for like a cylindrical object that has identical cross sections. This is my work. I don't want to really go over this, but I'm gonna do it from the beginning so we can just go over it together. So this is a cylinder, right? And what I like to look at is, okay, so this is the starting point, right? This is the line right here. This is what we're going to be measuring. And so if you twist it this way, so the spin is that way, all right, you're twisting up. This line segment is going to turn into a new line segment like this. So I basically was like, you know what, let me try unrolling this cylinder and basically just showing it how it looks unrolled, right? I should hurry up. So this is how it looks, right, essentially. And what we're trying to find is the angle of twist, which is right here. So we can just put this as theta. This is a right triangle. So the way you find a right triangle is the cosine of adjacent side to hypotenuse side. So I knew it was going to be cosine theta equals cosine something, these two sides. So all I really had to do was like figure out, okay, what is this and what is this? This was simple. This is like your original length. And since we're dealing with torsion, you have to incorporate the fact. So let me just write that. Cosine of, I like to put points. So I put this as Q, P, and R, right? I'm gonna have to flip this whole thing. All right. So Q, P, and R. So Q, this QP is going to be adjacent. So the length of QP. So the length of QP, I'm just gonna put that, just label it length. And then it's gonna be multiplied by the original torsion because like you have to know where you started with since we're dealing with torsion. But most likely it's gonna be like the standard like torsion, like you're starting at rest, so it's not gonna it's gonna be negligible for this if it's starting at like no torsion, zero torsion. So I'm just gonna put original torsion, and then it's gonna be divided by the hypotenuse. Yeah. So what exactly is the hypotenuse? So when thinking about this line, how is this line made? It's like the distance from here to here in relation to this. So how do you even find out where this point is, where R is? Well, we have to think about it, okay, how much resistance is, like, how far is it going to get from here to here? What are the two factors that kind of make this go from here to here? First is the shear force, like the shear, I forgot what is it, the shear constant, like in GPA. And like that's like inherent to every material. And then you also have to factor in the torsional force you're applying on it, right? So I basically, it's like these two have to basically combine together to get this point in a way, because we're still talking about torsion. We're not actually like talking about a coordinate graph. So after that, I was like, okay, you know what? Let's move on. So the shear GPA. This is for every materials has the same thing. So we're gonna just put that as X because like you're always gonna give them that. That's a given. That's like a constant for the thing you're using. And so the torsional force, what I basically was thinking about, I'm just calling it the torsional force. Like I'm pretty sure they call it something different. But right, you have to do like the change in distance, because this is really like a circle. If you flip it this way, it's a circle. And say your original point was at here, and when you rotate it, it's right here. So it all lines up, right? This distance from point A to point B has to be a part of that. So we can put this as R0 R1 for the changes in radius. So you have to subtract those two. R0 to kind of find what this is. And then you have to multiply that by pi over 2, which I kind of needed help with. I didn't, I'm going to be honest, like I don't, what I believe it is, it's because this is like a circle we're talking about. And to turn it from, okay, just the radius to something we can use in terms of this whole equation, you have to convert it into radians. So, yeah, you do that. So this, we're just going to put this as like A, capital A, and then multiply it by the shear constant. I'm just going to say S. Adult swim, that's funny. Yeah, that's how I kind of found out on what I believe is the length of it, the original length, and then the original torsional force. And then we have the shear for the material, and then the torsional force applied, which is like the change in the radius, the position of the radius multiplied by pi over 2. And that's how I found it.